Hello and welcome to this video on applications and problems with division and multiplication. So in this video we're going to use what we know about division and multiplication to answer some questions where we can apply our knowledge to some problems. So let's get started. By considering the value of the units, match each multiplication to its answer. The first one's been done. So I just want to run through the first one as an example. So we've got 54 times 38. I'm going to run through the whole thing just to highlight why we only need to check the units. So we've got 4 times 8, which is 32. So we write the 2, obviously carry the 3. 5 times 8, which is 40. So that will become 432 on the top. Then this is the important part. Because we're multiplying by something with the tens column, we have to obviously write our 0 there. So we've got 3 times 4, and that is 12. So carry our 1 down here, and then we've got 3 times 5, which is 15. Add the 1, which is 16. Adding that all together, we get 2, 5, 4 and 6 is 10. Carry the 1 down here, and then 1 plus 1. So 2052. So obviously we've got the right answer. So why do we only have to check the units, the 4 times 8 part? Well, this 0 here, because we're working with the tens, we have to write this 0 here, which obviously doesn't matter. It doesn't change what we have in this column, because when we add 0, we still end up with the same answer. So that's why we only have to check the units. So for the next one, we've got 127. And that's multiplied by 13. So again, we've got the same scenario. If we just do the units, so 3 times 7, well, that's 21. Then obviously we'd work the rest of that out. But then when we get onto this next line, we'd have to write a 0 here, so it wouldn't matter. We don't need to do the whole thing. We know that this is going to end in a 1. So we know, therefore, that this 127 times 13 matches to 1651. So that's sorted that. So in the next one we've got 65 times 36. Again, let's just check the units. So 6 times 5, well that is 30, so it will end in a 0. So we're quite comfortable in knowing that it would be 2340. It would match that because there's no others here that have a 0. Okay, so the last two, so we've got 48 times 38. So again, we'll just check the units. 8 times 8, 64. So this is going to end in a 4. So is there anything else that ends in a 4 other than 1824? There's not, so we'll match those two up. And then the last one, obviously by default, has to be 2279, but we'll just check it. So we've got 53 times 43. Again, we only have to check the units. 3 times 3 is 9. That ends in a 9. So we're happy. Explain why Thomas must be wrong. And Thomas says 36 multiplied by 93 is 3,349. So if we attack this question in the same way that we did the other questions, if we just check the units, well, checking the units, we've got 3 times 6. 3 times 6, that's 18. And then we know there's going to be a 0 down here. His answer should be ending in an 8, not a 9. So therefore, we don't even need to check the rest of it. Thomas is wrong. So therefore, Thomas is wrong. So find the missing digit. So 17 times 14. So we don't need to do the whole thing because we're looking for the unit, which is handy. So if we just check the unit, so 4 times 7 is 28. We know we're going to get a 0 down here, so the missing digit is 8. So the answer is 238. Problems, so find the missing digit. So for the first one, we've got 33 times 18. Well, 8 times 3 is 24. We know there's going to be a 0 down here. So obviously we don't need to work the whole thing out. If we add it together, we're going to get 4 there. So the missing digit for that one is a 4. Slightly different problem. 139 times 20 something is 3,306. Well, how are we going to get a 6 at the end? What are we going to have to times by 9 in order to get a 6 at the end? So if we think about our 9 times table, what is a multiplication when we end with a 6? And I'm quite happy thinking that that would be 4, because 139 times 24, well, that would be 9 times 4, which is 36. We'd get a 0 down here anyway, so that must be the only option. And then the final one, so 37 times by 40 something, so times by 40 something is going to give us 1,776. So what have we got to times by 7 to get 6? Well, that must be an 8, because 7 times 8 is 56, so it must be an 8. Then what we're going to do, we're just going to check the answers just to check that we've got them right. So I'm just going to use a calculator just to speed it up. So 33 times 18, well, that is in fact 594. Then 139 times 24, that is in fact 3,336. So 37 times 48, well, that is 1,776. So we're happy. So what have we learnt from those problems, from that series of problems? Well, we only have to check the units for questions like this, so we don't have to waste our time checking through the whole answer, because we know we're going to get a 0 here, so we just have to check our units just to get that last number at the end. So £4,113 is shared equally between 9 people. How much does each person get? So let's have a go at this. So we've got 4113. So I'll be doing the division like this. So 9 goes into 4 0 times, so we carry the 4. 9 goes into 41, 4 times, remainder 5. 9 goes into 51, 5 times, remainder 6. And 9 goes into 63 7 times, so we should get £457 there. So each person gets £457. Now we've got this question, so £5,362 is shared equally between 7 people. How much does each person get? So we've got 5, 3, 6, 2, and that's shared between 7 people. So I'll be using this method again. So 7 into 5 0 times, 7, so carry the 5 over, sorry, so 7 into 53, well 7 times 7 is 49, so be 7, remainder 4, 7 into 46, well that will be 6 times 7 is 42, so there's a remainder of 4, and then again 7 into 42 is 6. So each person gets £766. Okay, so in this question it says, shown below is a 2p coin. Each 2p coin is 0.185 centimetres thick. Stephen builds a tower of 252p coins. How tall is the tower? So, for this question, we've got 252p coins stacked on top of each other, and they're 0.185 centimetres thick. So to do this question, we are going to have to do 0.185 times 250. Okay, so I'm going to show you how to do this 2 ways. So the first way that I'm going to suggest is using Napier's bones. So obviously we'd have to draw our grid for this. If I just quickly sketch that out. So we'd have 0 and then 1, 8 and 5, and then we'd have 250 down the side. Okay, so we just draw our lines in. Obviously you have an advantage in your maths book that you will have the gridded paper. Let's draw all this in. Okay. Just finish this off. Perfect. And then we drop our diagonal lines in. So there's a diagonal line there. There's a diagonal line there. There's a diagonal line down there. This one here. And then the last two here. Right, so now we're in a place where we can start doing the multiplication. So 5 times 2, that's 10. 8 times 2, 16. 1 times 2 is 2. 0 times 2 is 0. 5 times 5, 25. 5 times 8 is 40. 1 times 5 is 5. And then 0 times 5 is 0. 0 times 0 is 0. And then the rest of these will be 0 because we've got 0 down here. Okay, and now we just need to add our diagonals up. So 0. 0 plus 0 plus 5 is 5. 0 plus 0 plus 2 plus 0 is 2. 0 plus 0 plus 5 plus 4 plus 6 plus 1. So 6 plus 4 is 10, plus 1, 11, plus 5 is 16. So write our 6 there, carry the 1 into the next diagonal. We've got 2 plus 1, which is 3. Add the 1, 4. And then that will be 0. And that will be 0. Okay then. So how do we know where our decimal place is going to go here? Well, if we think about it, we've got 0.185, so the decimal point will go there. Is there a decimal point, and we can obviously use the grid to help us here, is there a decimal point with this 250? Well, technically there is. There's a decimal point there and there's a 0, so it would be there. And then we just need to match the lines on the grid, so we just keep going across. So they will match here. Then we follow this diagonal, because this is where they meet, down, and our decimal point will go there. So therefore, our answer would be 46.25 centimetres. I said that we could use a slightly different method, and we could here. What we could do is we could work out 185, so 185 times 250, and that would have been 46,250. And to get 185, we've moved the decimal place 1, 2, 3 times, so we'd have to move our decimal place back to the left 3 times. So 1, 2, 3. And then obviously we arrive at the same answer, 46.25 centimetres. We're going to have a look at an interesting application of multiplication and division now. And we're going to use binary. So if you've done ICT, you should know that computers use binary. So binary is zeros and ones, series of zeros and ones. And it's called base 2. Why? Because there's 2 numbers. So the number system we work in is base 10. Why? Because we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the numbers that we have in our number system that we're used to. So that's called base 10. So in binary, the numbers are split up like this. So we've got the 1s, 2s, 4s, 8s, 16s and 32s. So if I write the number 1, so 1001, well that's 1 8, no 4s, no 2s and 1 1. So that'd be 9. So that'd be the number 9 in our normal base 10. And then if I multiply that by the number 101, well what's that number? That would be, so it's 1 4 plus no 2s plus 1 1. So that'd be 5. So if we multiply 1001 by 101, well, multiplication for binary works the same way. So we do 1 times 1, which is 1, 1 times 0, which is 0, 1 times 0, which is 0, 1 times 1, which is 1. Then we have to put a 0 for our placeholder. So it works the same way. So then we do 0 times 1, which is 0, 0 times 0, which is 0, 0 times 0, which is 0, and 0 times 1, which is 0. And then when we multiply this 1, we've got to add the 2 zeros. So just like we would with normal column multiplication that we're used to. So then we'll be doing 1 times 1, which is 1, 1 times 0, which is 0, 1 times 0, which is 0, and then 1 times 1 at the end, which is 1. Then, just like our normal column multiplication we're used to, we would add the rows that we've got up. So we get 1, then 0 plus 0 plus 0, which is 0, 0 plus 0 plus 1, which is 1, 1 plus 0 plus 0, which is 1, 0 plus 0, which is 0, and then we get a 1 here. So we get 1 0, 1 1 0 1. So our answer was 1 0, oops. So 1 0 1 1 0 1. So how do we convert that number back to something in base 10? Well, that would be our 1s, that would be our 2s, that would be our 4s, that would be our 8s, this would be our 16s, and our 32s at the end. So that number would be 132, so we'd have 32 plus no 16s plus 1 8 plus 1 4 plus no 2s plus 1 1. So 32 plus 8, well that's 40, plus 4 44, plus 1 is 45. And the numbers that we originally had in base 10 were 9 and 5. 9 times 5, well, that's 45. So we've ended up with the same answer. So that's just an interesting little run through of binary multiplication.